Imagine a small butterfly-shaped organ located at the base of your neck that holds the power to regulate your body's energy and metabolism. That's your thyroid gland, a fascinating little marvel of biological engineering. It's constantly at work, orchestrating the rhythm of your body's functions. This gland is particularly interesting because of its propensity to enlarge during crucial stages of life, such as puberty and pregnancy, and even under conditions of stress. This enlargement, while perfectly normal, is intrinsically tied to the formation of a substance called colloid. This viscous protein solution is crafted within the thyroid gland and acts as the raw material that is later transformed into thyroid hormones. These hormones, however, are not hoarded within the gland. Instead, they are released into the bloodstream as the colloid is broken down. Now, imagine the thyroid gland as a busy production factory. During periods like puberty, pregnancy, or stress, the production line speeds up. The colloid is formed at such a rapid pace that it can't be digested and secreted into the blood quickly enough, leading to the enlargement of the gland. But it's not just these periods of life that can impact the thyroid gland's size. Hormones like estrogen can also play a significant role. An excess of estrogen can put a spanner in the works, blocking the production of thyroid hormones. This leads to the gland enlarging as the pituitary gland secretes more thyroid-stimulating hormone, or TSH, to make up for the deficiency. So, the thyroid gland is a vital organ that plays a significant role in our overall health and well-being. But what happens when things go wrong? Stay tuned as we delve deeper into the impact of hormones like estrogen and progesterone on the thyroid gland, explore conditions like colloid goiter, and discuss the often misunderstood Hashimoto's disease. Remember, understanding our bodies is the first step to maintaining our health. Now let's delve into the world of hormones, specifically estrogen and progesterone, and their impact on the thyroid gland. Our body is a complex machine, with hormones acting as messengers, ensuring everything runs smoothly. Two key players in this system are estrogen and progesterone, each with a unique role in the functioning of the thyroid gland. The thyroid gland, during certain periods such as puberty and pregnancy, enlarges due to the formation of something called colloid. It is a viscous protein solution that breaks down into thyroid hormones, which are then released into the bloodstream. The rate of this process is influenced significantly by these two hormones. Estrogen, the primary female sex hormone, has a fascinating dual role. It stimulates the formation of colloid, but simultaneously inhibits its breakdown into hormones. This means that while estrogen is busy promoting the production of colloid, it also slows down the process of releasing those much-needed thyroid hormones into the bloodstream. Now, let's talk about progesterone. This hormone has a complementary role to estrogen. Progesterone is like the accelerator to estrogen's brake. It activates the digestion of colloid, increasing the release of hormones from the gland. This leads to a decrease in the accumulation of colloid. So what happens when there's a disruption in this delicate dance between estrogen and progesterone? Well, if progesterone levels drop, or if there's an excess of estrogen, colloid tends to pile up in the thyroid gland. This can potentially lead to the formation of a colloid goiter. It's a visible enlargement of the thyroid gland, and it's not always a welcome sight. It's a sign that the thyroid gland is creating colloid faster than it can be broken down and secreted into the blood. The balance between estrogen and progesterone is crucial for the proper functioning of the thyroid gland. If this equilibrium is disrupted, it could lead to problems, including thyroid gland enlargement and a potential drop in thyroid hormone levels. When this delicate balance of hormones is disrupted, it could potentially lead to the formation of a colloid goiter. But what exactly is this condition? Find out in the next part of our series. Picture an enlarged thyroid gland, a condition we refer to as a colloid goiter. But what causes this, and how does it affect our health? Let's delve into the science of it all. The formation of a colloid goiter is rooted in the intricate dance of hormones in our bodies. When progesterone levels dip too low or estrogen levels surge too high, the balance is disrupted. This imbalance triggers an accumulation of colloid, a viscous protein solution in the thyroid gland that is broken down into thyroid hormones. Now imagine this colloid as a bustling city. When everything is running smoothly, the city thrives. But when there's a traffic jam, things start to go awry. In the case of our thyroid gland, this traffic jam is the accumulation of colloid, which can lead to the visible enlargement of the gland or a colloid goiter. But the plot thickens. This condition can also lead to hypothyroidism. Why is that? Well, the hormones aren't being released from the stored colloid into the bloodstream. It's like having a warehouse full of goods, but no trucks to deliver them. The goods are there, but they can't get to where they need to be. This situation can be particularly tricky because an enlarged thyroid gland is often misdiagnosed. It's like a chameleon, blending into the background and masquerading as other conditions. For instance, it's often diagnosed as Hashimoto's thyroiditis or similar conditions. It's important to understand that these conditions are not one and the same. Hashimoto's disease is defined as the infiltration of the gland with lymphocytes, leading to the destruction of the gland's active tissue and resulting in hypothyroidism. So we see that the story of the colloid goiter is a tale of imbalance, accumulation and misdiagnosis. It underscores the importance of understanding our bodies, the delicate balance of hormones, and the potential consequences when this balance is disrupted. Interestingly, an enlarged thyroid gland is often misdiagnosed. Let's explore this further. Imagine being told you have Hashimoto's disease when in reality you might be suffering from a simple colloid goiter. A surprising revelation, isn't it? But this is the reality many face. An enlarged thyroid gland is often misdiagnosed as Hashimoto's thyroiditis, a condition characterized by lymphocytes infiltrating the gland, causing destruction of the gland's active tissue and leading to hypothyroidism. This misdiagnosis is primarily due to the reluctance in acknowledging that estrogen can indeed be pathogenic. The role of estrogen in causing thymus gland atrophy and its central anti-respiratory and anti-thyroid actions are not widely known among contemporary endocrinologists. Consequently, the presence of an enlarged thyroid gland is often hastily labeled as Hashimoto's thyroiditis or similar conditions. So what's the usual procedure for diagnosing Hashimoto's disease? Well, it typically doesn't involve a biopsy. Instead, it relies heavily on guesswork and the presence of anti-thyroid antibodies in the blood. But here's the catch. These antibodies are not specific to the thyroid gland, and their presence doesn't necessarily indicate a thyroid gland origin. In simple terms, the presence of these antibodies could be misleading. On the other hand, hypothyroidism, which is a significant cause of thymic atrophy, can be addressed with a thyroid supplement that stimulates the regeneration of the thymus. This correction of the thymic portion of the immune system by the thyroid hormone is likely involved in the observation that antithyroid autoantibodies decrease under the influence of supplemental thyroid hormone. However, the supplement also affects the thyroid gland by decreasing thyroid-stimulating hormone, leading to inflammation like stress and disordered structural changes in the thyroid gland. In essence, the frequency of simple colloid goiter and the development of Hashimoto's autoimmune thyroiditis should not be overlooked. Instead, understanding the mechanisms involved in the production of autoantibodies can help us see thyroiditis as usually the last stage in the development of a simple colloid goiter. The misdiagnosis of thyroid conditions can lead to improper treatment. So, how can we address this issue? That's a question we'll delve into in the next segment. Addressing thyroid health effectively requires a deep understanding of the mechanisms involved. Let's dive deeper into the relationship between the thyroid gland and the body's overall health. Hyperthyroidism, an underactive thyroid, is a significant cause of thymic atrophy, the shrinking of the thymus gland. This gland is part of the immune system and is responsible for the development of certain immune cells. When the thymus shrinks, it can't perform its functions effectively, leading to a weakened immune system. However, there's a silver lining. A thyroid supplement can stimulate the regeneration of the thymus, thus correcting the thymic portion of the immune system. This is likely involved in the observation that anti-thyroid autoantibodies decrease under the influence of supplemental thyroid hormone. Yet, it's important to note that thyroid supplements also affect the thyroid gland directly. They decrease the thyroid-stimulating hormone, which can lead to inflammation like stress and disordered structural changes in the thyroid gland. Therefore, it's essential to approach thyroid supplementation with care under the guidance of a healthcare provider. Now let's talk about autoantibodies. These are antibodies that mistakenly target and react with a person's own tissues or organs. Understanding the production of these autoantibodies can help us see thyroiditis, inflammation of the thyroid, as usually the last stage in the development of a simple colloid goiter. This perspective shifts our understanding of thyroid health and its interconnectedness with our immune system. A more efficient production and use of thyroglobulin, a protein produced by the thyroid gland, will decrease the tendency of the overstimulated gland to produce a defective globulin that is antigenic. That is, it triggers an immune response. This could further help in addressing thyroid health by reducing the chances of developing a simple colloid goiter and eventually thyroiditis. Optimizing thyroid health is crucial for overall well-being. Remember, understanding is the first step towards healing. The journey towards better thyroid health starts with education and understanding. Let's continue this journey together, learning more about our bodies and how we can support their optimal function.